Assalamualaikum and salam sejahtera to UMS CoFA, Secretariat, colleagues and friends. My name is Noshina Herani Binti Haris from Faculty of Engineering, and today I will be talking about Earthquake Vulnerability Index of buildings in Kota Kinabalu. And did you know more than 50% of earthquakes in Sabah are between magnitude of 4 and 5? Already experienced damage on buildings, and how our current buildings will sustain the loads from earthquakes in the future. This shows the plate tectonic movement focusing in the Malaysia region. From the south, we can see the plate tectonic called Indian Australian plate move towards to Malaysia, and the movement is about 7 centimeters per year. And on the east side, we can see the Philippine sea plate move 10 centimeters per year, and Malaysia is actually sitting on a Eurasian plate that moves downward or southeast with 4 centimeters per year. Where do the earthquakes take place? At first, we need to know the theory of plate tectonics. This theory states that the movement of plate is because the Earth's upper layer has a greater strength than the below layer. When Earth's tectonic plates green if past one another, enormous amounts of energy can be released in the form of earthquake. For example, given these two layers of interplate earthquake and interplate earthquake, an interplate earthquake is an earthquake that occurs at the boundary between two tectonic plates. If one plate is trying to move past the other, they will be locked until sufficient stress builds up to cause the plates to slip relative to each other. The terms of interplate earthquake refers to variety of earthquake that occurs within the interior of a tectonic plate. This stands in contrast to an interplate earthquake which occur at the boundary of the tectonic plate. So most earthquakes are a result of fault movement in the crust, a relatively thin layer on the Earth's surface. The earthquake occurs within the crust to a depth of about 25 kilometers. This figure shows the fault source, what will be its intensity when the buildings close to the epicenter, how much damage the building carried, and how much shaking the building will experience. For example, when an earthquake happens, we can see that the building that is closer to the epicenter will feel the higher intensity and sustain a very heavy damage and experience an extreme shaking in comparison with the buildings that located in far from the epicenter. In here, we can understand that Kota Kinabalu is not far from the epicenter and might feel the earthquake shaking coming from around our area and probably receive an earthquake from light to moderate. So the objective of this study is to determine a vulnerability index of building structures in Kota Kinabalu. So this study has compiled the earthquake recorded from the year of 1900 until recently. So we have compiled all the earthquake recorded data from the magnitude of 2 until the largest 8.9. So we can see that from our neighboring countries such as Philippines and Sulawesi, we have they have recorded the largest earthquake, which is from the Philippine area, with a magnitude of 8 in 1976, and on the 12th August, just recently, they have experienced the latest earthquake, which is equals to magnitude 7. And around the Sulawesi region, they have experienced several of big earthquakes, such as in 1905 with magnitude of 8.3, in 1936 with a magnitude of 8.6, and in 96 with a magnitude of 8. This is the latest statistics of earthquake in Sabah region from the year of 1900 until recently in 2020. Sabah has recorded the first earthquake in the year of 1902, whereas the magnitude is 4.2. Then the largest ever recorded was in 1976 with a magnitude of 6.3. And we already experienced in 1923 with magnitude 6.3, and in 1955 with magnitude of 6.1, and in 2015 the magnitude also is equal to 6. From the records of Sabah earthquake, there is a trend of increasing seismicity throughout the region, and there is a possibility of this earthquake more than 6 happen in the future. The seismicity is the occurrence of frequency of earthquake in a region. It can be measured from its occurrences, mechanism, and the magnitude of an earthquake. On this right figure shows the distribution of Sabah earthquake with a total more than 500 of low to moderate magnitudes from magnitude of 2 until 6.3 have occurred in this region. And from this figure, the seismicity of Sabah, we can see the distribution of seismicity from the center around Ranau, and then around Kudat and Lahad Datu area. Earthquake in Sabah is the most common hazard, and it poses a threat not only to people but to the environment. It is essential to raise public awareness on that matter. From the earthquake data statistic and plotted with different districts such as Kinabatangan, Beluran, Sandakan, Semporna, Tawau, Kudat, Lahad Datu, and Ranau, with a magnitude range of 3 to 6, we can see that Ranau has the most recorded earthquake, then followed by Lahad Datu. And then if we plot on the map the location of Ranau to the site of interest, which is the area of study in Kota Kinabalu, we can see that the fault line in black color, and the distance between these two areas is approximately 100 kilometers. So this can be considered as a near-field earthquake. So here is the history of building damages to earthquake in Sabah. Well, when an earthquake strikes, purely designed and constructed buildings are a major contributing factor to the eventual size and scope of the catastrophe. In many ways, it can be said that it's not earthquakes that cause human injury and loss of life, but rather it's buildings that are inappropriate design, such as soft and weak stories, short column, strong beam, weak column, and in-plane or out-of-plane movement of the walls causes damage. So here are some of the examples of damages happened in Sabah region previously. So the first is in the year of 1976 with the magnitude of 5.8 in Lahad Datu. The walls of the ground floor of the new police complex at this area were badly damaged. Cracks appeared in other buildings, including the telecom building and low-cost houses. And in 1983, the magnitude is 5.1 located in Tawau. The cracks appeared in the general hospital and in the residence office. And then in 1991, with the magnitude of 5.1 occurred in Ranau. The school suffered structural damage, brick walls collapsed and crack produced. This event also produced a landslide. And in 2008, with a magnitude of 5.1 in Kunak area, this earthquake have caused minor cracks on the floor and walls of the supermarket and minor damage to the concrete base of an oil palm storage. And the 2015, with the highest magnitude, which is 6, happened in Ranau, whereas there are 23 schools in 6 different districts affected, and most was also damaged due to the tremor. And the serious damage occurred also in the area of hostel and rest house near to the Mount Kinabalu. And this 2018, the magnitude is 5.2, and the location in Ranau. There is a minor damage on the climbing route. So in the previous literature review that have done the vulnerability studies on Sabah buildings, they either use qualitative method or quantitative method. So for example, Adnan in 2006, the area of study in Labuan and Kudat, they have done the method using the qualitative method. And Ismail in 2011 around Kota Kinabalu, Sandakan, Labuan Tawau and Kudat using the qualitative method. And Ghaffar in 2015, their area of study in Ranau has done on the quantitative method. And Mansur in 2017, there are so many area covered. They have used both qualitative and quantitative method. And Muhammad et al. In 2019, the area of study in Ranau used the quantitative method. And this one is Janice and Haris in the area of study in Kota Kinabalu has done on the quantitative method. And from previous study regarding the story of building, so most of the study has done around the Malaysia region. So they have tested the buildings with low to mid-rise story. So and then from their results, they suggested that their moderate level of damage will be affected for these buildings when subjected to moderate earthquake. This is methodology has conducted for the current study. First, we need to compile the building information around Kota Kinabalu and identify its building usage and refer to the National Annex of Malaysia to see the design values. And we will locate the building and how much will the building expose to the earthquake. And from that, these two data will be compiled in order to determine the building characteristics and vulnerability. And then we will identify the site typology, the geology, and the geotechnical information around the buildings. So this is the example of some buildings that has been included in the current study. For example, Yayasan Sabah that has been built in 1976. So the story of this building is 32. And LHDN built in 2000 with 10 story. And Pusat Pentadbiran Negeri Sabah that built in 2016 with 33 story. For residential building also included in our current study. For example, we have Jal Sultan Residence built in 2017 with 28 story and One Borneo with built in 2008 with 28 story. So this is the map published by the JMG or Jabatan Mineral and Geoscience Malaysia that's showing the design value for the structural engineer in order for them to include the seismic design parameters into their structure design. So this map is published in 2017. We already experienced the earthquake from the 1900s. So we have that in mind that how vulnerable of this building that built before that. So that's why this study has done some analysis in order to check whether the buildings, especially in the Kota Kinabalu, is vulnerable to the earthquake coming in the future. So as referred to the Malaysia National Annex 2017, so the engineer must design the building or structure based on the design PGA value. So for example, under class 1, we have a minor construction. So the engineer must design the construction. The design PGA is equals to 0.1 G. So under class 2, for ordinary buildings, such as low-rise buildings, so the engineer must take the design PGA equals to 0.12 G. For class 3, buildings of large occupancy such as condominiums, shopping center, school, and public building. So the engineer must take into account the design of PGA equals to 0.14 G. And then last one, class 4, for lifeline built facilities such as hospital, emergency services, power plants, and communication facilities. So the engineer must design the building based on the design PGA value equals to 0.18 G. From our field survey, we have managed to compile all the buildings with respect to the number of story. So for the less than 3 story, we have 62 buildings in around Kota Kinabalu, and for less than 6 story, we have compiled 83 number of buildings, and more than 7 with total number is 102. And from these buildings, we can see that the function of each building, that most of the building in Kota Kinabalu consist of residential, commercial, office, and school. There are also other types of building, such as the assembly building, utility, commercial plus office building, commercial plus residential, and assembly office school, assembly utility, and other types of building. So here is the list of building and with the respective soil type. So we have go under different districts around Kota Kinabalu. As for example, Damai, Sepanggar, the city of Kota Kinabalu, Lintas, Menggata, Putatan, and Tanjung Aru. And we have managed the total of building is around 250. That most of the building we have covered on the city of Kinabalu, and we look into the soil type for each of these district, and we managed to identify its soil type based on the site investigation. So most of these buildings are sitting on the soil type C and D. So in the terms of the soil type, whether the following building types are covered in the FEMA guideline. The description of each of the 17 structural system of model buildings types is given in this table, such as FEMA building type includes the wood, steel, concrete, precast, reinforced masonry, unreinforced masonry, or manufactured. So we have to assess a field survey required and observe the type of building around Kota Kinabalu city using a standard FEMA forms. From the survey, it can be observed that buildings in Kota Kinabalu are mostly made of concrete, and then some of it are made of steel and precast. And from FEMA guideline, we have to identify and calculate the RVS score for each of the buildings. So from this table, we can see that the RVS score for less than 0.3 considered as a high probability of grade 5 damage, that a very high probability of grade 4 damage, and 0.3 between 0.3 and 0.7 is a grade 4 damage, 0.7 to 2 is a grade 3 damage, 2.5 is grade 2 damage, and more than 2.5 is grade 1 damage. So from here, if the building is more than 2.5, so there is no observations, means that the buildings is okay in terms of their construction, but we have to be careful if the building is less than RVS score 2.0. And from the buildings in Kota Kinabalu has been plotted into this bar chart. So we can observe that there are 7 buildings is actually less than 0.3 with the high probability of grade 5 damage, and between 0.3 to 0.7 is the total buildings is 137, and less than 2 with 90 buildings under this category. And with or more than 2, there are 13 buildings that are for high probability grade 2 damage and grade 1 damage. So from here that we can observe most of building in Kota Kinabalu is probably the probability of grade damage 3, 4 and 5. So from the conclusion, from the vulnerability index result, the total of score between 0.3 and 0.7 show the highest number, which indicate heavy structural damage and very heavy non-structural damage. These are 90 buildings considered as moderate structural damage to heavy damage, and 7 buildings with very high structural damage from near to complete collapse. So the building contains RVF score of more than 0.7 will be recommended for further detailed vulnerable analysis because of the acceptable probability of collapse of existing building is given to value of S of about 2. So based on the result, there are 94.7% of the survey building recorded the S value below than 2. So this indicates that further investigation and detailed measures are required. Thank you for listening. That's all for my presentation. Thank you very much.